specific heat capacity and calorimetry. Specific heat capacity is basically an intrinsic property, which means this property is dependent on the substance. It is unique to the substance, which means it is different for every different substance. And what is it? Specific heat capacity is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, for example, if you look at water, the water, in order to increase the temperature of 1 gram of water by 1 degree Celsius, the amount of heat that is needed is 4.184 joules, which means the specific heat capacity of water is 4.184 joules for every gram and every degree Celsius. So the unit that is commonly used is joules per gram degree Celsius. This is joules per gram degree Celsius is the SI unit. Another unit that you might see sometimes used is calories per gram degree Celsius, because joules or calories, these are two different units that are used for energy. Okay. Specific heat capacity, we can also usually abbreviate it as small c. Whenever you see small, in small case written C, that means we are talking about specific heat capacity. Okay, and how can we measure heat that is involved in any process? Heat is usually given by the abbreviation Q. Q represents heat, and it's given by the formula Q is equal to mc delta T. This symbol triangle that you're seeing here, whenever you see triangle, that simply means it represents difference in the two quantities, difference between initial and the final states. Okay, so for example, in this case we see delta T. Delta T means it is final temperature minus initial temperature. It's always going to be final minus initial. And what is this formula? Here Q is equal to mc delta T. Sometimes students also like to memorize it by calling it Q equals mcat. Because this kind of looks like A, so they call it mcat. Easier way to remember. But basically what this is, Q here represents heat. Heat can be in any unit, joules or calories, right? Or calories. Okay, let me just rewrite that. Heat can have multiple units. It can be either joules or calories. It can be kilojoules, kilocalories. M here is the mass of the substance, which is grams. C here is the specific heat capacity, or it's also called just specific heat. Delta T here means it is change in temperature. So Fahrenheit, final minus initial. It can be in degree Celsius or Kelvin, doesn't matter. You just have to subtract and get the difference. This slide shows you specific heat capacity for different substances. So you can see here aluminum, copper, every substance has its own specific heat capacity. What does this actually mean? For instance, if we compare let's say water, liquid water, the heat capacity is 4.184 joules per gram degree Celsius, right? Joules per gram degree Celsius. Whereas if you look at copper, it is 0.385 joules per gram degree Celsius, which simply means that if you heat copper and water at the same time, if you start heating them at the same time, copper temperature will rise a lot faster than water. Why? Because you can give unless when you give copper 0.385 joules of heat, the temperature will increase by 1 degree Celsius. But when you give water 0.385 joules of heat, its temperature is not going to increase by a degree Celsius until you give it 4 joules of energy. So that basically you can see is almost 10 times heat. So in the same amount of time, if you give the same amount of heat to both copper and water, temperature of water will only increase by 1 degree Celsius, where copper will increase almost by 10 degrees Celsius. Okay, and that is because of its specific heat capacity. The compounds or substances or elements that have a low specific heat capacity, like this, low specific heat capacity means temperature will increase faster. Temperature increases faster. If they have high heat capacity like water, then the temperature will increase slowly. That is the reason why water and water-based compounds or water-based solutions are usually used to make the solutions in case of car. Okay, like antifreeze or coolant solutions that are usually made in car, those solutions are usually made up of water based, because water has a very high specific heat capacity. So water can actually absorb a lot of heat from your car, but the temperature of water will not increase that much. Okay, based on these equation that you saw, Q is equal to mc delta T, we can try some questions. Calculate the number of joules of heat. So question is asking what is the joules required to raise temperature of 123 grams of water from 14.7 to 31.3 degrees Celsius. Specific heat capacity of water is given. So the information that is given to us, this question is asking find the joules. 123 grams of water, meaning mass, is given to you. This is mass. Temperature goes from here to this, which means this is the initial temperature in the beginning, and this is the final temperature. Initial temperature means temperature at the beginning, final means temperature at the end. And this is the specific heat capacity, which means this is the small c. And the question is asking how much heat is released in joules. So what is heat? Q is mc delta T. So we can just simply plug in all the values. Q is going to be 123 grams times C 4.184 joules per gram degree Celsius times change in temperature, which will be 31.1 minus 14.7 degree Celsius. If you work with units, gram and gram cancels, degree Celsius cancels. At the end, the unit that we are left with is joules. Now plug in these numbers in the calculator and solve for your answer. Finally, your answer should have minimum and maximum 3 sig figs, because based on this, all the calculation, multiplication, your final answer should have 3 significant figures. When plugged into the calculator, the answer I get is 8439.964, and I'm looking for 3 sig figs, so my answer should end 1, 2, 3 right here. The following digit is 9, which means I'll round the number up. It will become 8440, and I will keep this 0 as the placeholder because this digit that I'm getting rid of lies before the decimal, so you can't change the place value. This 8 is on the ones, tens, hundreds and thousands, so this 8 is 1000, 8439. You can round it up to 8440. You cannot change the place value of this number 8. If it was 1000, it should still stay at 1000. Let's try another question. Calculate the specific heat of water if 83.68 joules is required to raise temperature of 4 grams of water by 5 degrees Celsius. So 4 grams means this is mass, by 5 degrees Celsius means this is already delta T. This is the change in temperature that is needed. Then we have 83.68 joules, which is Q. Joules is the unit for energy, heat, which is Q. And the question is asking what is the specific heat, meaning what is C. The equation that relates all of them is Q is equal to mc delta T. Q is given to you, M is given to you, delta T is given to you, and question is asking you to solve for C. If I want to solve for C, I need to isolate C in this equation, which means I want C on one side of the equal and everything else should be on the other side. How will I do that? If I divide this by M, then M and M will cancel. If I divide this by delta T, then delta T and delta T will cancel. And what I'm left with is only C, which is what I want. Which means if I divide the right side by M and delta T, I have to do the same on the left side. So Q will be divided by M and divided by delta T, and that is equal to C. So if I divide this, I also have to divide this by M and divide this by delta T. Now plug in your equation, everything in the equation. Q is 83.68 joules divided by mass, which is 4.00 grams, divided by delta T, which is 5.000 degree Celsius. If you work with units, no units cancels, which means your final unit is joules per gram degree Celsius. This is 4 sig figs. This is 4. I'm missing a 0. Question gives you one more 0. This is 4 sig figs. This is also 4 sig figs. So my final answer should have 4 sig figs. If you plug this into your calculator, it will give you 4.184 with the correct number of sig figs. And that's your final answer. The next concept is calorimetry. What is calorimetry? Calorimetry is a technique that is used to study how much heat is being transferred during a given reaction or during a given process. It is the study of heat transfers by measuring the temperature change that is involved in the substance. So it's a technique to measure how much heat change is involved. How will we do this? Usually a calorimetry is done by using a device called a calorimeter. What is a calorimeter? We most probably will do a lab using this approach. So please understand, because you will need this approach for your calculations in the lab as well. Okay, what is a calorimeter? It is basically an insulated device, kind of that looks like this. It's completely insulated. You can see here there's a outside container, and then there's a container on the inside, and there's insulation here. Okay, and it's all insulated, which means the heat cannot be lost outside. The heat will not go out of this flask. For example, kind of like your thermos flask that we usually use to carry food or water. It keeps it cold or it keeps it warm. Why? Because it's insulated. Very similar, but this is a little better version of that. Okay, so this is insulated. Heat cannot be lost outside to the outside of this flask. What does it consist of? It basically contains a container inside which is filled up with a certain amount of water. There's a thermometer connected here, and there's a stirrer. So you can stir the solution. Let's say I want to, I took a piece of metal. This is my metal object, and I heated this, okay, with like a lot of heat. That's my flame, okay. The metal got heated up. As it gets heated up, I take this metal and I drop it into the water. What would happen to the, as you drop it into water, the water is cold, metal is hot, so the heat will transfer from the metal object to water. The temperature of water will increase, okay, and we can measure what is the initial temperature of water before the object was dropped, and at the end what was the final temperature of water that was reached. So using that, I can calculate what is delta T of water. I can measure how much water I'm adding in here, so that would give me mass of water. And we already know what is the specific heat capacity of water. If I know all these three things, I can calculate what is Q of water, meaning what is the heat that water absorbed, which will be mc delta T, all for water. And where is all this heat of water coming from? All this heat of water is coming from this piece of metal that I added, which means the heat that water absorbed the heat, so I will call it a positive heat, increase in energy, is equal to all the heat that was lost by the metal. So water absorbed the heat and metal lost the heat. Whenever any substance loses heat, we usually represent with a negative sign. This is, the sign is not telling you the energy is negative, it's simply telling you direction of flow of energy. Whenever energy is lost, heat is lost, we usually represent it by a negative sign. So heat that was gained by the water is equal to the heat that was lost by the metal. And using this approach, using this mathematical expression, we can solve for any missing information about the metal. So for example, heat for water, meaning m of water, c of water, delta T of water. Heat for metal will be m of metal, c of metal, delta T of metal. So if I am missing any of this information in this equation, I can find that information. If I want to know what is the c of metal, I can rearrange this equation and solve for c of metal. If I want to know what is the mass of the metal, I can rearrange this equation, solve for mass of metal. So that is what calorimetry does. It's a technique that can help you understand the amount of heat that was transferred during any process. Okay. Let's try some questions based on this technique. A 25-gram sample of metal is at 87.7 degrees Celsius is placed in 37.4 grams of water at 10 degrees Celsius. And the final temperature of the system is 15.4 degrees Celsius. Calculate the specific heat of metal, and the specific heat of water is given to you. Okay, so it's a lot of information. Let's separate the information. What's given to us? 25-gram sample of metal. So mass of metal is given to me 25.0 grams at 87.7 degrees Celsius, which means this is the initial temperature of metal, 87.7 degrees Celsius. It is placed in 37.4 grams of water, which means I have water also. Mass of, I'll write H2O, water, is 37.4 grams at 10 degrees Celsius, which means this is the initial temperature of water, 10.3 degrees Celsius. And the final temperature of system is 15.4 degrees Celsius, which means final temperature of everything combined. Always the final temperature, always your final temperature for everything will basically be same, because water and metal will reach the same temperature because they are together. So temperature final for metal is 15.4 and temperature final for water is also 15.4. Final temperature would always be same for both. Calculate the C of metal. I need to find what is C for metal. And C for water is given to us 4.184 joules per gram degree Celsius. Which means, how can we solve this question? This is a question about calorimetry when two things at different temperatures are mixed with each other. So remember, heat, that because the metal is hot, it was 87, it became 15. So which means it became lower in temperature, it lost the heat. So heat gained by water, gain means positive, is equal to heat that was lost by the metal. Lost means it is negative. And what is Q of water? It will be M of water, C of water, delta T of water is equal to negative M of metal times C of metal times delta T of metal. Okay, what am I solving for? Water is given, C is given, T is given for water, M is given for metal, T is given for metal. I'm just looking for this C of metal. So I need to rearrange my equation so I can isolate the C of metal. How can I isolate? First thing I see here is there's a negative sign. So if I divide this by negative, which means I also divide this by negative, right? Then if I divide this by M of metal, this cancels, this cancels. So I divide this by M of metal. I also divide this by delta T of metal, which means this cancels, this cancels. So I also divide this by T of metal. And only thing that's left is C of metal, which means this is equal to C of metal. So if I just now need to plug in all the numbers here. Okay, what is mass of water? Mass of water is 37.4 grams times 4.184 joules per gram degree Celsius times delta T of water, 15 final minus initial, 10.3, everything degree Celsius, divided by, there's a negative sign, so that means everything's negative here. Mass of metal 25.0 grams. Delta T of metal, final temperature of metal is 15.4. Remember that. So it would be 15.4 minus 87.7, not reverse. It's always final minus initial. Now you just plug it all into the calculator and solve for it. This degree Celsius cancels. This grams cancel. What are we left with? Joule over here divided by gram degree Celsius. Plug all these numbers into your calculator and you get your final answer. The final answer I have is 0.44 joules per gram degree Celsius. If you get that, you are basically done. And why is this 2 significant figures and not 3? Because when you solve for delta t is 15.4 minus 10.3. 1 decimal place, so your final answer should have 1 decimal place, which means this is 5.1. When you plug 5.1 in here, this and this is 2 sig figs. So that's why my final answer is 2 sig figs. Question could also look like this. Okay, calculate the final temperature. So I need to find what is TF. After 6.8 grams of aluminum, this is metal. C of metal is given to you, C of aluminum is given at 67.4 degrees Celsius. So metal is at 67, which means this is initial of metal. Is placed in 195 grams of water, so this is mass of water at 19.6 degrees Celsius. So this is initial temperature of water. C of water is also given to you. Question is asking what is the final temperature. Okay, remember final temperature for each of them would be same. Okay, so how can we calculate this? Same approach. Q of metal loses, so negative, equals to Q of water. You put M, C, delta T all for water on this side and M, C, delta T all for metal on the left side. And this is negative. And again, what you're doing is, in this case, your delta T will be your final minus initial. So in this case, it would be T final minus 67.4. And plug in the mass, plug in the C. From here, mass is 6.80 grams and C is 0.892 joules per gram degree Celsius. This is equal to water, 195 grams. C is 4.184 joules per gram degree Celsius, and delta T is your final TF, which we don't know, minus initial, which is 67.4 degree Celsius. Okay, now you're rearranging these equations and solving for TF. Okay, so when you solve